Okay, so what I want to do this morning is what I want to do is just answer any questions from chapter 1. See how you're doing. If we're all doing A-okay today, then I will put together an assignment this morning and get it for you sometime tomorrow, and then we can approach chapter 2 probably on Monday. I suspect there should be, I'm hoping there are some questions from this morning or for this morning from chapter 1. No questions today?
Could we do one of the questions on page 52, like one of the question 11 questions?
Sure we can. Of course. Let's do it. All right. So, question 11, it says, find the number of terms in the geometric sequence. So we have a geometric sequence, which means that so my general term for a geometric sequence is t to the n equals t to the 1 times rn minus 1. So the first thing I do is I try and identify what t to the 1 and r are. So t to the 1 in 11a is 3, and it looks like my r is 2. So to find out what t to the n is, this is a good question. I'm glad you asked this. Actually, I thought I did this one yesterday maybe, but all right, no worries. It's all good. So I have 1536 equals 3 times 2 to the n minus 1. Just like that. So the first thing that I do is I divide by 3. Okay. Now, in grade 12, we would be able to solve this question if this base and this base were completely different. But in grade 11, we can't do that. So what we have to do here is we have to change 512 to 2 to the power of something. And it's going to work every time. All right? It will work each and every time. So this is 2 to the power of 9 equals 2 to the power of n minus 1. So now, if this side is equal to this side and the bases are equal, then that means the exponents have to equal each other. So I go 9 equals n minus 1, n is 10. So the 10th term of the sequence is 1536. Okay, so far, Tessa?
Yeah.
All right. Okay, I'm going to try one more then. I'm going to try one that's a little bit more difficult. I'm going to look at well, let's look at B. Okay, so I've got t to the n equals t to the 1 r n minus 1. Now I always like starting writing that out, because for one is it tells me that I'm working with a geometric sequence, so that's ideal. Okay, number 2 is it gives me an indication as to what I need to find so far. So t to the 1 and r, I need to find those. So t to the 1 is minus 409.6. My r, just gotta grab my calculator here. So I take, well, I'm gonna cheat a bit here. 409.6 divided by 102.4. It's 4, yeah. So this is my, and it's a negative 1/4, I believe. Yes. Okay. So I have t to the 1, I have r. Now I got to work with minus 0.025 equals minus 409.6 times negative 1/4 n minus 1. Okay, so now what I'm going to do is I'm going to divide this over to this side. So I'm going to take 0.025 and I'm going to divide 409 minus 409.6. And I need to go math, enter, enter. Oh, that didn't work well. Okay, so I end up with something I don't like. Now, what is going on here? 0.025, 409.6. I thought this would work out to a nice easy fraction, but it hasn't done that for me. It's a quarter. Okay, so 0.025 divided by 409.6 is that. Okay, I don't like what's happening here. Now the reason I don't like it is because I'm getting this as my value, 6.1035 times 10 to the negative 5. That's equal to minus 1/4 and minus 1. Okay, so far I have a bit of an issue here. The issue is I need to somehow get this to be 1/4 to the power of something. So I'm gonna fiddle with this. I don't like the way we're doing this question, so I'm gonna show you one, how I'm gonna get myself out of this situation that I have, and then number two, I'm gonna show you how I could do this question a little bit different so that it makes more sense. So what I'm gonna do right now is I'm going to put, because I have 1/4 here, negative 1/4. This actually is a negative here, negative 1/4 here. I'm going to test my calculator, and I'm gonna put 0.25 to the power of something to get to that value. So I'm going to go 0.25 to the power of 9. Not quite far enough. 0.25 to the power of 11. Wrong direction. 0.25 to the power of 7. There it is. All right. So I did this by using trial and error. Not ideal. But what I'm doing here, and this is the important part, is I know that this value right here has to be able to be put into 1/4 to the power of something. That means I have to match these bases up in order to solve this question. That's what that means. So I would get 7 equals n minus 1, n equals 8. Okay? So I am using the fact that I knew what this base was and that this had to be negative 1/4 to the power of something to get that value. Okay? Now, there is a different way I could have solved this question, and I would suggest using this once in a while if you're really struggling to get the bases equal to each other. And that is this. All right? I'm going to take this question again. I've got minus 409.6. I've got 102.4 minus 25.6. And now I'm going to just keep dividing by 4. So 25.6 divided by 4 is 6.4. Divided by 4 is negative 1.6. Divided by 4 is 0.4. Divided by 4 is 0.1, negative 0.1. All right. 1, 2, 3, 4, 5, 6, 7. Holy. Divided by 4, there it is. That's the other way to do it. If in this question here, I didn't like, and I was really struggling to get these bases to match up, Tessa, all right, I would just find out what the ratio is and keep going until I hit my value. That's okay. There's nothing wrong with that. There's my 8th term. That's how I solve it. Okay? So that you can use whichever way works best for you in this situation. All right? Okay? So I'll leave C and D for you. All right? Because one's easier and one's a little bit. Go ahead.
Thank you.
All right. Sorry, say that one more time, please, Tessa.
I said thank you.
Oh, you're welcome. Sorry, I'm just looking for it over and over again. Just the assurance. That's what I was looking for. No, that's okay. All right. Anybody else have questions this morning? I'd ideally like to see you get through this today, but go ahead, Austin.
Question 9 on page 51, if you could, please.
Absolutely. Okay, so I've got s to the n equals negative 441 for the series 19 plus 15 plus 11, all the way to t to the n. Determine a value of n. Yeah. Okay. So I've got $441. Okay, so one of the things that we have to determine, all right, now, I always struggle with these questions until I get going and I get into a groove. So I'll do the best I can. So I have a series of 19 plus 15 plus 11. So what I am seeing is that I have a common difference here. So my t to the 1 is 19. My common difference is negative 4. Okay? And I am looking for the value of n in which my sum, so I need to use one of my sum equations. So my sum equation is n over 2. And I never remember what they are, so you got to excuse me for a second. There it is. N over 2, 2t to the 1 plus n minus 1 times d, I believe. Like that. Okay? And so I am looking for n in this case. I have minus 441 equals n over 2, 2 times 19 plus n minus 1 times negative 4. All right, so that's what I'm looking at right now. So the first thing I would do is I'm going to times the 2 up. So that's minus 882 equals n. And then I have 38 minus 4n plus 4. Okay, so this negative 4 has to go through the brackets. Negative 4 times n is negative 4n. Negative 4 times negative 1 is that. So I have minus 882 equals n. 42 minus 4n. Okay? So now I am looking at a quadratic equation here is what's going to happen. So I'm going to go minus 882 equals 42n minus 4n squared. I'm going to move everything to the same side. So I have 4n squared minus 42n minus 882 equals 0. No easy way to do this. I would divide everything by 2. And now I'm going to factor that to try and get that so that I have values there. All right, so let's play around with it and see what I get. So I got 882. I'm just going to rewrite this over here. product minus 882, sum minus 21, factors. Okay, so 882 divided by 4, let's say. Nope. 882 divided by 16. Nope. 82 divided by 8. Nope. 3. So 3 and 294. One possibility. So 9 and 4 make 33. So that must mean 882 divided by 9. So I get 9 and 98. 98 is 49 and 2. 49 minus 18 is 31. Rats. Oh, I guess I could do this. Well, so I'm still working through this. So that'd be 63 and 14. That's not going to work. Okay, let me go back and make sure I haven't made any errors. I don't see any errors. Anybody see anything we've got wrong here?
No, that's exactly what I had, and then I just gave up.
Well, there's got to be a whole number solution to this. There's got to be one solution that's a whole number, but I can't figure out how you would get there. Did you see the answer? Did you see the answer in the back?
Yeah, it's 21.
It's 21? All right.
Yeah.
Okay, well, let's try it using this. So I got 21 plus minus square root. 21 squared, is that 441? So I have 441 minus 4 times 2 times negative 441. 2 times 2. I don't think there's any possible way I can get, so 441 plus 8 times 441, that's 3969. Wow. I'm missing something over here then. Definitely missing something over here. Because this is 21 plus minus 63 over 4. So let me just check something. 82 times 63. Oops. 63 and 14, but that still doesn't help me. I got that down here. I don't know. It's blowing my mind. It has to be factorable. Okay, I'll tell you what they are right away. 21 and 63. 84 divided by 4 is 21. And 21 subtract 63. There's the reason there. So it isn't factorable, but that's weird. There it is. So there should be a way we could get this factored down.
Mr. Newton,
Yeah. Go ahead.
Tesla did it.
Cass, you did this?
But just 2 sides stick.
Okay, come on here, Tess.
Yeah.
Did you factor it?
Well, I just put it into the equation.
Into the, like what I just did here?
Yeah.
Yeah, okay. But you didn't factor it, did you?
No.
See, I think there's a way to factor this. I mean, none of my numbers want to work. Oh, yes, there is. I'm missing something here maybe. What if I do this? 3, 3, 7, 7, 2. So now I have 21 and 42. There it is. Rats. Sorry, gang. There it is. If I do this, and then 3, 7, and 2. Let's try this again. This was factorable. But we did do it using that quadratic equation is fine. Nothing wrong with that, okay? But this is factorable. My product was minus 882. My sum was minus 21. And my factors are 42, negative, and 21. Like that. So now I go 2n squared minus 42n plus 21n minus 441 equals 0. Take my 2n out, that leaves me at n minus 21. Take a 21 out, leaves me at an n minus 21. Okay, so I'm left 2n plus 21, n minus 21 equals 0. So n equals negative 21 over 2 and 21, and it has to be a whole number. Sorry, gang. Brain's not functioning this morning, but we got her. All right, it was factorable. And just to show you, because this stinks, but this is where we started when we did greatest common factor. We went into prime factorization. And so what I was trying to do here is find numbers that I could break down and then multiply them differently to get to where my sum needed to be. And what I missed was that 9 is not a prime value. I should have had the 3 times 3 in there. Okay, so 3, 3, 7, 7, 2. So 3 times 7 gave me 21, and 3, 7, and 2 gave me 42. That's what led me to it. So my bad. Tessa, good work. Don't be shy. We need help. Even I do. Especially me. Maybe that's what I should have said instead of even I do. There's moments. Okay, so Austin, you good?
Yes, thank you.
Yeah, no worries. No worries. All right, any other questions this morning that you want to go through, gang? How many of us, just give me a yes or no or whatever. I'm just trying to figure out where you're at. Did most of you get through the end of page 52? Quick yes or no.
Yep.
Yeah. Yeah, I'm basically to that point.
Okay.
Yep.
All right. Okay. So basically what you have is 53 and 54 today. Geometric series and infinite geometric series. So the infinite part's not bad. The geometric series part might be a bit of an issue. So how about 924? Let's stay on for another 20 minutes here. And unless you want to go through, I can go through these with you as well. What do you guys want to do? Do you want to do them on your own, or would you like me to go through a couple of one from kind of each section? What would you like?
I personally would prefer to do it on my own.
Okay. Anybody want me to go through them?
Would you be able to do like one example from each page just to make sure we're on the right track? Like one from page 53 and one from page 54.
Oh yeah, absolutely. Okay, let's do. All right, let's do 17A. I'll do that. Okay. So 17A starts 960. So t to the 1 is 960. T to the 2 is 480. T to the 3, 240. T to the n is 15, and it wants us to find out what the sum of this geometric series is. So to find the sum of a geometric series, okay, I'm just going to go back again. Like I told you, these equations are so close together. I never remember them. Infinite. Come on. Here we go. So I have t to the 1. Over, is it 1 minus r minus 1? R minus 1. All right. So my r in this case is 1/2. My t to the 1 is 960, but I do not know what the n value is. So the first thing that I need to do is find out what term 15, where it falls in. Okay? So I go 15 equals, let me do this again. T to the n equals t to the 1 times rn minus 1. So I've got 15 equals 960 times 1/2 n minus 1. I'm going to divide the 960 over to the other side. So I want to see what that is as a lowest terms. So this becomes 1 over 64 equals 1/2 n minus 1. 1 over 64 is 1/2 to the 6, goes 1/2 n minus 1. N is equal to 7. So now I'm looking for the sum of the first 7 terms. So I can use this. Now here's the thing. I said this before, and I don't have a problem with you doing this. In fact, I may even encourage it a little bit. All right? I could expand this out. All right? Let's say I kept going. So I have 960, 480, 240, 120, 60, 30, 15. And there's nothing saying that you couldn't just add those together on your calculator or in your head. I don't care. Add them together, and that gets you the sum of those terms. That's okay. You can use your equation as well. So t to the 1, 960 times 1/2 to the 7, subtract 1 over 1/2 minus 1. Okay? So I'm just, yeah, everything looks good. All right. So then use your calculator to do it. So I've got 960 times bracket 0.5 to the 7th minus 1 bracket divided by, and that would be minus 0.5. So I would get 1905. Okay? Add these up together, you would get 1905. That's okay. There is nothing wrong with that. That is a method that works. It's probably an easier method for you to do without having to calculate through, because lots of us will mess this up on our calculator. So check your answer, check your solution, 1905, check your solution, 1905. Okay? So that was 17A. And let's have a look at let's do 20. Let's look at 20C. Okay, so for 20C, I have 6.1. T2 is 1.22. T3 is 0.244. So the first thing I'm going to do is calculate my R. I always use 3 to calculate my R. The reason being, I'm mostly concerned that I may make an error if I only do it one time. So to me, it looks like my R value is 1/5. Okay. Now, because my R value is a fraction, I have a divergent infinite geometric series. So infinite means it goes forever. Divergent means it comes towards one value, okay, on it. So I can use s to infinity equals my t to the 1, which is 6.1, over 1 minus 1/5. So that's 6.1 over 4/5. Use your calculator if you have to. 7.625. Now this one doesn't work as well if I were to continue to add these together. And the reason it doesn't is because it's an infinite series. So, and an infinite series keeps going and going and going. So I need to use this simple equation. So the equation is, sorry, I should have wrote the equation at the top, and I didn't. For an infinite geometric series, t to the 1 over 1 minus r. Okay, so that kind of gets you through, that leads you into those last 2 pages that you have to do. All right, any other questions this morning? Okay, so if we can get that finished, I will, what's today, Wednesday? I will likely do a bit with chapter 2 tomorrow then. Because like I said, we got about 12 days or so. I'd like to get through maybe 5 of these reviews so that you can get as many assignments on them and try and work your mark up. So I'm going to start on chapter 2 tomorrow. I'll go through that if you finish chapter 1 today, and I will try and get an assignment together for you to give you tomorrow. Okay? Any other questions, concerns? We're all okay? Getting outside, it's nice and warm. Plenty of golf being played by everybody, or is that just me?
Plenty of friends at the golf course, but.
Oh, good for you, Amy. You keep it going out there. Amron, you as well.
I've been out golfing once so far.
Nice. Nice. Good stuff.
I'll be going out more times.
Absolutely. It's the only thing that we can do nowadays. Perfect. All right. Everybody have a good afternoon. It should be warm enough for you to get outside and play golf. And I'll talk to everybody tomorrow morning, same time. Okay?
Thank you.
Okay. Have a good day. Talk to you later. Bye.
Thank you. Yeah. Thanks. Bye. See you tomorrow.
You bet.